We're here at Bluebell Hill Studios in Kent, in England, in the beautiful English countryside. And we're here in this gorgeous studio to talk about our Brick Lane 500 Modal PWM Compressor. So like never failed, right, Ed? I mean, like no matter what we came out with, the Carnaby's, you know, when we released the Camdens, when we did the racks, when we did the cast boxes, whatever we came out with, the question inevitably followed. When are you guys making a compressor?
Every time.
So 7 years on, and you know, working on and off on it.
Yeah, I've been throwing ideas around and working on it on and off between projects for a long, long time now.
Yeah, and here we are. Finally, it's here. Our Brick Lane 500. Our take on compression. What is a modal PWM compressor? So if you break it down, modal and PWM. So I'll let Ed talk about the clever stuff with the PWM. But modal is talking about how the compressor works. So it's the real key is understanding that switch right there, the mode switch. So that will fundamentally transform pretty much everything about the compression. Most analog compressors have a gain element, which is fixed. It has a way that a compressor works. So that could be an opto cell, it could be a FET, it could be a tube for Varimu compression, whatever. It has a physical component which gives it its ballistics, its compression behavior, its envelope, its the onset, all the things that make a compressor, that make it unique. That's kind of fundamental in the components of an analog compressor. What's cool about the Brick Lane 500 is that all of those characteristics can be changed and can be adjusted to be basically anything. So we've come up with the term modal to describe completely changing the compressor's behavior. Everything from the detector, the detector circuit of what's activating the compression, the curve of the compression onset, the knees, the differential rate of change. I mean, just literally everything about the compressor can be tuned and adjusted and changed. And we have 6 modes on the unit, which we think give the 6 main styles of compression that most people are looking after and looking for. And it's not just 6 emulations; it's 6 absolutely amazing versions of those styles of compressors. We'll get into why each model's so great, but basically it's 6 compressors in a box that you can choose between effectively, and that's what the modal means.
So PWM stands for pulse width modulation. Effectively what you're doing is you are switching the audio on and off at a very, very high frequency, over 250 kilohertz in this unit. And then the proportion of the time it's switched on for versus switched off after the reconstruction filter, which gets rid of those switching frequencies later, gives you an exact reduction in gain proportional to the ratio of the time it was on versus it was off. So if you have it turned on half the time versus turned off half the time, you end up with exactly a division by 2 in the gain, so you end up with exactly minus 60 dBs on the output. And this is great because it's a perfect ratio, so you know exactly the amount of gain you're going to get from it, which, given that precision and that control, is what enables us to do all of the modal characteristics and the switching of behaviors. There are other kinds of PWM compressors, of course. We weren't the first company to do it. We've made some modifications on the thing. We've improved the concept and got a much improved filtering and faster switching frequency and all the rest of it to get much lower distortion than previous designs. But fundamentally, the reason we chose PWM versus other compression mechanisms for our design is that we needed that control. We needed that ability to incredibly quickly and know exactly what gain we were going to set within a few nanoseconds. The precision of the PWM is completely outside of, is on a whole other level than any of the other compression technologies, and that's what enabled these behaviors in the modal compressor. So we have attempted to make the cleanest, fastest compressor in existence. We went and studied the actual achieved performance of various other designs, not just when they weren't compressing, but also when they were. Usually you'll find that some of the other technologies like VCAs, they can get reasonably low distortion until you start really cranking the gain reduction, and then the distortion rises dramatically. Previous PWM designs also had significantly more distortion than any other part of the modern high-quality audio recording chain. We've managed to achieve, I think the raw input to output THD figures are somewhere in the 4%, THD kind of range. Under compression, that never really goes past around 201, it's minus 6 dBs. I've seen about 0.0008% THD. So it's a very, very low distortion.
And that's with like 20 dB of gain reduction too. That's not.
That's the worst case.
Yeah,
was what I was seeing. It actually gets better, at lower gain reduction.
So not a 3 dB, the 3 dB, 5 dB compression, no problem. I'm talking about 20 dBs of compression. It's still 3 zeros.
It just pushes everything down further and further into the noise floor. You won't see distortion characteristic rising up from the actual compression itself. And of course that then gives us the flexibility to add in the saturation and completely change the characteristics, because the compression element itself doesn't add it.
I've personally, I've used loads of analog compressors over the years. Yeah, I've been blessed to work in a lot of cool, awesome big studios with, gorgeous outboard gear. And, when we first built the Brick Lane 500 and we listened to it, I had never heard a compressor that was clean, like an analog compressor that was that clean. It just doesn't exist in the world. And at first it was like a bit strange, because I was squashing something with 20 dB of gain of reduction, and I wasn't hearing it. It just was lower. I was like, is this working? Like, what's going on? Is this a volume control? Like, why is this doing this? It's just I'd never heard that before. And now that I know it, and now that I've heard this clean of a compressor, again, even with extreme gain reduction settings, it's transformative. It's a really, really unique sound compared to most compressors. You don't really realize how much distortion most compressors are adding until you kind of use a Brick Lane and you see the difference. And of course, a lot of those distortion characteristics are great, and we've tried to emulate them in some respects with the stress circuit, but a lot of the artifacts are not so great. They're not the sort of analog distortion that you want. It's not nonlinear, even order, asymmetric clipping and stuff like that. It's that optical element is giving up, or that VCA can't switch fast enough. That FET just has that distortion, that has that noise there, that artifact there. The Brick Lane 500 just doesn't have that. And we're not talking about it at one frequency either. It's 20 hertz to 20K. Distortion increases as the frequency increases. You get closer to the switching frequency. But the distortion is still vanishingly low. 3 zeros pretty much across the frequency range, even with pretty extreme gain reduction settings. So a totally different compressor than anyone's ever heard before. One of the big contributing factors to the clean performance and the speed of the Brick Lane 500 is Lookahead. So Lookahead, people that use DAW compressors, which is most people that record these days, they're used to Lookahead in their limiters and the brick wall limiters and all that kind of stuff, and it's crucial in digital compressors. Lookahead is a great feature, but crucially you have to understand that it's taking recorded material that's already sitting there as a data file on your computer, on your hard drive. It's reading the data from that file, and then informing the compressor before the signal is actually running through it. So it's able to pre-apply compression before the signal actually hits it. That's the way Lookahead works in a VST. But crucially, again, that can only really happen in the digital world, and it can only happen with pre-recorded material. You can't have Lookahead if you're live tracking into a digital compressor, nor would you want to. But the point is that it's a constraint of having something pre-recorded. But analog Lookahead, like the Brick Lane 500 has, doesn't work that way. Ed, you could kind of explain how you found this, I guess.
Yeah, so I kind of found it in the simulator by accident at first and thought I'd made a mistake or there's a bug in the simulator, because it was, the output was going high before the input, which didn't seem to make a lot of sense. But I did some digging around and actually found that in the RF industry they have been using these negative group delay filters, and it's it doesn't actually break the laws of physics. It's a very band limited and very constrained phenomenon that you can only do for about a quarter of a wavelength of effective Lookahead. The circuit that we've got uses multiple bands for this phase rotation negative group delay to get that quarter wavelength Lookahead, and that enables us to have more Lookahead at the lower frequencies where you really need it, because those are longer wavelengths, and need that gain reduction in advance. It's a very unusual technology that really has only been used anywhere in the world for just the last few years. So we're quite excited to put it to use in a musical context.
So for anybody who's familiar with our stuff, you know that analog saturation is near and dear to our hearts. So, you know, we have the Candon 500 and the Candon series preamps that has Mojo, which is analog saturation that's designed to emulate and like preamp style saturation. Then we have the Carnaby, which is a harmonic EQ, which is just throw out the rules about saturation. What can we do with saturation? And that was make a whole new circuit. We have a saturation core, which create harmonics, which generates an EQ effect. Those two circuits are completely different. They're two totally different types of saturation. And now we have a third type of saturation, which we call stress. And that is dynamics-focused, compression-focused saturation. So when you're using a compressor, the sort of saturation artifacts you're going to get are from stressing the compression element, driving the compression element beyond what, it's maybe designed to do or pushing it pretty hard to generate these dynamics focused saturation artifacts. And so that's what stress is. It's a dynamic effect. So it only comes in when the compressor is working, unlike, the Mojo of Candon and Carnaby, which are level dependent. So they do respond to dynamics, but they don't gate in or come in when just when the signal goes above a certain threshold. It's always there on and then just more saturation over time. Whereas on the stress circuit, the stress comes in when the compressor comes in, like it would do on a analog compressor, that you're driving hard to get that gooey, gnarly sound that you're after from a vintage compressor. So the stress does that in a very controllable way, variable, with 6 different modes to really dial in the flavor that you're looking for. In the modern studio, plug-in compressors do a lot of heavy lifting these days. Analog compressors are still used in the tracking phase, on mix buses and on mastering, but, plug-in compressors do a lot of the heavy lifting during the mixing stage these days. And digital compressors are really great. They're clean. They have Lookahead. They can apply compression perfectly. You have multiband. You could do all this fun side chaining stuff in your DAW. They're really powerful. They're really great. But the key thing is a digital compressor, the audio has to already be in your DAW to use it. So whenever you're in the analog realm, if you're tracking with your mics, you have a drummer, you have a guitarist, whatever, your vocalist, if you have a lovely preamp and you're trying to get a performance, you're trying to get a tone to inspire the vocalist, a digital compressor is maybe not the best tool for that job. An analog compressor in your analog chain, to pair with your preamp to get a sound and to inspire performance from a vocalist is a pretty popular way of using analog compression these days. Equally, a lot of people, they'll do a lot of the heavy mixing tasks in the DAW with plugins, but then to kind of bring some kind of analogness back into it, they'll bust out the mix bus and then they'll have an analog mix bus chain. And whenever you're in analog, if you're going to be applying, saturation, EQs, whatever your output processing is on your analog mix bus, compression really wants to be with that before the converter, especially because you don't want the converter to clip, because converter clipping is not desirable. It's not the nice type of clipping. It's the nasty type of clipping. So you always want to catch the stuff before your converters. And for that task alone, an analog compressor is great just before the converters. But also analog compressors are used, to generate tone. For instance, mix bus compressors are often the very first thing in a mix bus chain because it just gently massages everything together and kind of puts it all together, glues it together for then the rest of the mix bus chain, the analog mix bus chain. And then in mastering, a lot of mastering is done in analog too, or hybrid. Maybe it started in analog to get some of their best analog pieces, but then goes back into digital, especially because when you're talking about loudness, to get the last bit of loudness out of the track, that's at the moment quite tricky to do in the analog realm because you need a limiter that's fast enough to catch any rogue peaks before the converter. And some converters have like clipping circuits just before the converters, which can help get that last bit of loudness. And that's what the Bricklane 500 does in polish mode. So it's a ridiculously clean, fast limiter. capable of 0 attack time, so it can be a brick wall limiter with infinite ratio compression. But then the stress circuit on the polish mode is a clipper. It's a clipper designed to get loudness, to get LUFS in a master. So it's a really great analog compressor for all the analog compression tasks that you have in a modern studio, right? Like analog compressors don't completely replace digital compressors, but digital compressors don't completely replace analog compressors either. You're in analog, you use analog compressors. When you're in the digital realm, you use digital compressors, if that makes sense. We like to name our analog signal processing circuits after places in London. We're a London-based company. We're all quite inspired by London. It's a wonderful, city that really has everything that you can imagine in the world, almost pretty much on your doorstep. Camden was named after a really cool area of London where lots of music's going on, markets, lots of energy and vibrancy. Carnaby's named after Carnaby Street, in the 60s where all the cool thrift shops and the flower power kind of hippie movement was kind of centered in London. And then Brick Lane is named after Brick Lane, which is an area in East London. It's kind of known for a bunch of things. It's known for the bagel shops. It's known for the curry houses. But what's really cool about Brick Lane, the area, when you go there, it's just really vibrant. There's lots of street art. By Shoreditch High Street, there's the big tunnel where there's loads of street art there. On a Sunday, they have the markets. There's like beatboxers in the street doing things. There's various musicians busking and people playing like drum and bass or dub or reggae, whatever. It's just a really vibrant area. Big melting pot. Lots of influences. Lots of stuff going on, and it's just a big, vibrant, fun area with lots going on. And it's also kind of a pun on brick lane, brick wall limiting. So that's why we kind of went with Brick Lane. We thought that was a fun inspirational place in London to name a compressor. So one of the biggest challenges of the 500 series format is the space envelope. Obviously, power and current's a problem too, especially with like component count. Like we have, I don't know, what is it, 1,700 components or something like that in the Brick Lane? It's something ridiculous. Like 10 times more than most other 500 series modules because of the complexity. But by far the biggest challenge with 500 series is space for the controls. So I think on the Carnaby we kind of maxed out, what we're comfortable with in terms of having controls. It's not too fiddly, but I think any more than that would just be too tight. It would just not be very nice to use, which presented quite a challenge when you have hundreds of parameters that you can adjust on a Modal PWM compressor, which was a little bit of a conundrum, Ed. Like, how do we make this work?
It was. We didn't even know what the front panel was going to be for a long time. We were experimenting with the stress circuits and the PWM compressor and the control of it we had, and we ended up with a list of, I think it's 125 parameters within the software that get adjusted from what ended up being the different modes. So we wanted a user interface that got you there quickly. You don't want to be lost within settings paralysis. And so we found that there were 6 major use cases and a variation for a 7th that covered 99% of what you want to do with the thing and let you get there with just a couple of button presses. So you can flick to the mode. You want to do mastering limiter, you flick to the mastering limiter mode. It'll adjust all those parameters for you, get you right in the ballpark. You tweak a few controls and you'll be there. There are options to get into those advanced parameters and customize. Like if you want to change the ratio, you can push that to the right and flick between different settings. So that's increasing the ratio as I go through. And there are further deeper modes. There's an Enigma mode, which
for those who are really bold.
Yeah. Exactly. But 99% of the time you won't even need that. You'll just flip to the mode you need, adjust the knobs, and you'll be there.
So the Brick Lane 500 is just loaded with innovation and research and time and work and effort and care and attention. And we didn't even go into stuff like the various detection modes. We have 9 different detection modes, and the stereo side chaining is done in a very clever way as well. That we think, after getting mastering engineers' feedback, we did it to the way that they thought it would be best to not collapse the stereo image. Just various things like that. We can't even go into all the details. Like the phone system multiband saturation, the crossovers are linear frequency response. There's lots of little innovations in the Brick Lane 500 that, we don't even have the time to go into. But the point here is just the care and attention, the time, the craft, the care, the love that's gone into this. and how much, you know, we like doing that. And that's what we're here for to do. You know, you got to get out of bed and do something every day, right, Ed? I mean, and, you know, I guess we could, you know, we can make other boxes. We could clone stuff, make counterfeit products like other brands do, whatever. But there's enough of those guys doing that. And what's missing currently in the world is kind of genuine innovation in the analog domain. You know, back when Rupert Neve and Graham Blythe and Joe Meek were doing those things, you know, these things didn't exist, so they had to make stuff. They had to innovate. They had to create things. Whereas now, you know, in the audio world, we only really see true innovation pretty much in plugins.
There's such a, you know, it's such an easy tool set for people to develop within and make changes that it just attracts all of the, you know, all the research and development, because it's the easiest way to solve problems. It may not necessarily be the optimal way. You know, there are situations when going out into the hardware world really does make a difference, but it's just so much easier and cheaper to make progress within
some
the
DSP.
world.
Yeah, exactly. Whereas, you know, analog electronics, it's also law of diminishing returns. I mean, we're really, you know, even take converters these days. Converters are so good these days.
They're very good.
You know, even like an entry level converter is quite good, you know, compared to what we had 15, 20 years ago when I was in recording. You know, pretty usable, even entry level stuff. And then, okay, obviously the best stuff is wonderful, but, you know, could we do better than the most wonderful stuff? Yeah, probably. But, like, will you really hear the difference? Tight. Whereas Bricklane 500, I mean, you will absolutely massively tell the difference. It's night and day. And what's also cool about the Bricklane, you know, obviously all the innovation in it, the sound is totally different than anything you've ever heard before. Obviously, we have the modes which are meant to be inspired by those compression types, but because when you have a clean, fast, perfect compression element, such as the PWM circuit, strapped to a multiband saturation circuit, that combo is extremely powerful and is unlike any compressor that's ever existed. And that's why we get out of the bed at the end of the day, to make something that's, you know, inspiring and cool and that we could be proud of. And indeed, we are very proud of Bricklane 500, and we're excited to get them into all your hands into the world very shortly.